Hi, so this is a video to present our installation scheduling software. So this is a software that we've built for one of our clients and is actually our biggest project so far. It was also very successful, so we wanted to present how it went. So I have this Royo that I created yesterday and today, and I wanted to go through the context, so with the problem statements, what we've analyze that we should improve, then the different options that we've explored, what we finally went with, and after this, show you what the tool actually looks like, and also a short conclusion on like what was the impact of using this tool and building this tool for this client. So we were working with an energy renovation specialist who's installing smart thermostats across France. So that's essentially IoT sensors that you plug to your heaters, and then you're going to be able to control the temperature in every single room in your house from your smartphone directly. So people are also able to create scenarios, etc. So they make actually good energy savings with this. So they rely on lead list to get the clients. So the lead is composed of one phone number and a name. Then they have the sales step, which is essentially one telemarketer. They have about 20 of them that is going to call the prospect to confirm the interest and also check the eligibility for the renovation program because there's a few conditions. Then they now have a client. So now they have the address and the eligibility that is confirmed. And we're going to go on to the step of the scheduling to schedule the actual installation. So they have 8 schedulers that are calling the client to get their availabilities for the week, and they also propose specific times. So that's 4 hours block. And the reason why they give 4 hours block is although the installation takes between 1 hour and 1 hour and a half, they will give a bigger slot to the person, to the clients, to make sure that they're at home and they don't run errands during the slot, or it's just a way of like reducing the no-shows, right? Then comes the time of the actual installation. So you have at a specific date and time, a technician, so they have about 25 of them, goes to the client's address. So as I said, is about 1 hour to 1 hour and a half, depending on the number of heaters, so the size of the house, essentially. And the real bottleneck here is the scheduling, because schedulers, they have to find a slot when the client is available and they have a technician nearby. And it's a bit of the chicken and the egg problem, because you don't really know when you're going to have a technician nearby before you actually schedule your first appointments. So that's what you really need to solve. And the way they would do it, it was by saying, so we're gonna make a technician. So they all live, most of them they live in the Paris region. We're gonna send one to the south of France, and on the way down to that city. So I think we can do, for example, Bordeaux, which is southwest. On the way to that city, they're gonna go through this and this and this regions. So let's try to find people that we can install on the way. So they would target the technician reaching Bordeaux on Wednesday by leaving on Monday. So on Monday, they would go down to the south. There's a few cities on the way. They would call people, try to tell them, okay, are you available Monday morning to get an installation? No. Yes. They start to build the timetable like this. But you see how tedious it can be. And if you get called for a very specific day at a very specific time, you might not be available. After 2 or 3 times, you get fed up and then you just stop replying. So that's why we also observed their conversion rate. So they have the conversion from a lead to a client, they lose about 20% of them, which kind of makes sense because there's people that are not eligible, they're not interested anymore, and there's just people that maybe made a mistake when they filled the information, the phone number is wrong, for example. Then from a client to installation, that's where there's the biggest loss because they lose about 60% of the traffic. So we identified that this could be improved. And how do we improve the conversion rate? Is by simplifying the process and reducing the friction. So how do you reduce the friction here? We thought, okay, let's try to make it fit in a single call. So during the telemarketing call, so the sale, we're going to be able to directly check the eligibility, check the interest as usual, but also propose an installation time. So schedule also. So we started looking at the existing route optimization software that's known as the traveling salesman problem, and think about your local Amazon delivery guy, your local postman, for example. They need to go through a number of stops and they just want to look at the optimal route, right? So here we have the map of the US. Let's consider that we need to go through all of these red dots. Then the blue line is the best way to do so, by minimizing a cost function. In that case is the distance. The only problem with this is that if you change the position of one dot, it can change a lot also your route. So it requires all the addresses to be known in advance. Otherwise, it can change the whole schedule when you change a single dot, a single stop. So we looked at software that were available, so there's Upper, Routific, or Route for Me. But the problem again is that it's not suitable for managing dynamic leads with uncertain availabilities. So we concluded that we need to go for a custom software implementation. So that was to develop a tailor-made solution integrated with the CRM. There was no other software that was integrated with the CRM actually, so that was a big plus. And then that during a sales call, given an address, you're able to propose installation times directly and to, with a button, a single click to put it back into the CRM and update the schedules. So we want to feature real-time scheduling connected to technician's calendar. We also have the location, so that's ideal. Compute the travel times and also recommendation system to favor slots when the technician is already close by to reduce the distances. So yeah, so this is what it looks like. So we have the CRM that is connected to our Supabase database. So the webhook, we built it in Python. The idea behind this is that the CRM was not very modular. So we wanted to do our operations on the Supabase database. We then have our Python backend, which basically for given an address, will list all the possible installation slots. So that means in the technician's timetables, do they have some time available? So it's at least 1 hour plus half an hour at least of commutes. So if they have 1 hour and a half of time, then we make it as we mark it as an available slots. Then we have an API to convert addresses into coordinates. So this is then to compute the straight line distance. And on this, we had to do a bit of tweaks because this API doesn't always work because addresses are approximative. So we'd have a system that would correct the addresses before doing the coordinates conversion. And then we would, of course, make sure that the coordinates were good. So, for example, that it fits within the French territory. Otherwise, you probably have an error, actually. So, and we have a first filtering where we make sure that the geodesic distance, so the straight line distance, is not greater than 50 kilometers, because in that case, we probably don't want to install this client at this time. And then we have the API to measure the travel times. So it's like a real road distance. And it takes care also of like this estimation about the traffic jam. So we cross-checked it with our database from the paths that they collected with the commute times from a point to another, and we're able to correct a bit the estimations. And we also try to rank it by travel time after in the interface to favor just installations slots where we have a lower travel time. On top of this, we create a Streamlits interface. So there's a Python library that allows you to create graphical user interface. We highly recommend it. It's actually not that scalable because I think the maximum is 100 users, concurrent users. However, in our case, like we would never reach this because they don't even have 100 employees. So we're good on this front. And it's just the best way to prototype and gets like, you're going to see what the app looks like. It's already pretty complete. You have a couple buttons. The only issue is that you need to load to change information on the page, you would have to reload the page. So that could be a deal breaker for some of the applications. In that case, we'll probably use like a React front end, but that's what we went for this example, for this project. So here is what the app looks like. So you have essentially your address that you input. So there's the name of the street, the city, and the zip code. Then you have a viewing mode. So in that case is telemarketer, but you also have a debug mode to help the schedulers that would still like need to check that everything was fine. You have your search button, and it's going to give you per day the available slots that you have. So again, you only communicate to the client the 4-hour slots. So here you have the morning, 8 to 12, the afternoon, 12 to 4, and then the evening, which is 4 to 9. So you can propose the 3 slots to your clients. Once you click on one of those buttons, you have you have it here. You have all the details of the installation. So we know the actual exact time of the installation, which we actually don't communicate. It's just going to be in the timetable of the technician. We're going to put this. We have the name of the technician, the distance for the trip, and the time that it's going to take. So in that case, it's very short, it's 8 minutes. And then after that, we added a button to synchronize with the CRM. So directly when you click on a button, you agree on a installation date with the client, and you can directly update the timetable of the technician. Okay. So one of the problems that we've encountered is that most of the technicians, they live in Paris. So I think out of 25, 14 lived in Paris. So what we did is that we printed the map of France. Here you have the blue circle, our 50-kilometer radius around addresses of technicians that do not live in Paris, and the ones that live in Paris. So is the red cluster, the red circle in the red cluster is Paris region. So most of them, they live there. And what they would do before having the software, they would basically send them to the south of France. So they would say, okay, we're going to send one to Poitiers here. So we know on Monday it's going to go all the way to Le Mans. So everybody that is on the way going to try to install them. And then on the second day, it's going to go there, and so on. Although this doesn't work very well, because again, like, the clients, they get exhausted of being called over and over. So we chose to have a proactive approach. So we removed all the historical appointments that were within a 50-kilometer radius of the addresses of the technicians that do not live in Paris. Then we clustered, we had 14 remaining technicians, and we clustered the remaining in 14 using the DB-scan algorithm. Highly recommend, is very convenient. And we were able to define these clusters and to assign one technician to each cluster for a single week. So why does this problem come from? Is because say that all our technicians, they start from Paris, then we have an installation in Rennes here, which is about, like, I guess like 300 kilometers from Paris. So it's not going to be within a 50-kilometer radius of our Parisian technician's address. So we're actually never going to be able to install these clients. So we want to just send the technicians over there at the beginning of the week, and they stay there for the entire week, and to cover, like, all the installations that they would receive during that week. So these clusters also have, like, equal weights, meaning that they have an equal volume of installation. So we keep each technician as busy as the others. And it's actually very important because they work by commission. So you need to have about the same volume. So these are the AI bricks that we've implemented. So we have a travel time estimation where we use API and also historical data to correct it. We have the ranking system that we use to push an installation that we want to favor up the list. So in the case that I mentioned, like, it's when we have a shorter distance to go through. And we have the technician zone attribution using the clustering that I just explained. So the final results, we tripled the conversion rates of the clients, and also their profit margin, because they did not increase their spendings on leads. So with the same amount of leads, they would triple their conversion rate, thus tripling their profit margin. We reduced the time spent by the schedulers. So 6 out of 8 started working as telemarketers after. We also reduced the average distance between appointments by over 20%, just by favoring the appointments with a shorter distance to travel. We cut the no-shows by 8%. This is probably due to having a more streamlined and faster process. So which means that the clients, they trust you more. And a faster turnaround time to find a substitute installation in the case of a no-show, to still keep the technician busy, because you already went to that address. We try to find someone that is around there. And a significant revenue increase by leveraging existing leads. So it's a bit, the conclusion of all of this is mainly on the revenue. Then, so on the product delivery, we had a first functional prototype that was demonstrated 3 weeks after we started the project. And the tests, they started after 4 weeks, so with 3 telemarketers and 1 scheduler. And then we rolled it out for all the telemarketers during the 6th week. So you see here that we had a couple of weeks to fix all the bugs that we found and integrate properly with the CRM. Yeah. So let me know if you have any questions on this, especially maybe on the software, the way we build the software. I think there's quite a bit of things that we did there, quite a lot of complications that we found. But yeah, and so if you have an idea, a problem, or you're just curious, feel free to book a 30 minutes coffee chat with us. We'll explore how AI can help transform your business, help streamline your processes, etc. We can work on anything. We usually start with an audit to kind of understand how you work. That's the part that we did here at the beginning. And then we build the solution for you based on what you actually want. We make several propositions. So you can visit our website, and also you can book this call on our Lemcar page. So this is going to be on our website. Again, like you will find, I think there's a single button, so it shouldn't be hard to find it. All right, thanks a lot.